So I would like to move to our last, but certainly not least speaker. I would like to call Mrs. Dr. Maria Gavrouzou, which is an associate researcher at Demokritos, and she holds a PhD in atmospheric physics from the University of Ioannina Physics Department, and an MSc degree in atmospheric sciences and environment, and a BSc in physics. And currently she's a member of the Environmental Research Laboratory in Demokritos, and she's involved with the multi-climate project. And her topics should be about energy interventions that contribute to the climate proofing of buildings on multiple scales. Thank you very much.
Good afternoon. Thank you, Mr. Padelidis, for the introduction.
Sorry.
Yes, I think. Okay, today we will discuss about the energy interventions that contribute to the climate proofing of buildings on multiple scales. Here is an overview of today's presentation. First of all, we will discuss about natural hazards related to climate change, the effects that they have on building stock in Europe. We will suggest some energy interventions that will contribute to the climate proofing of the buildings. We will discuss the advantages and disadvantages of some solutions, and we will close with some conclusions and the perspectives for future work. I know that you have already heard about the natural hazards and the climate change from the previous presenters, but this is the truth, and climate change is happening now, and this is an important issue. In this slide we can see at the left part a diagram with the monthly anomalies of the temperature. These values are global mean values, and as we can see, they refer to the month September. As we can see, last September was the second warmest one globally, based on the ERA5 dataset, and Europe also had the second warmest September on record. Much of the continent also experienced above average precipitation, with storm Boris causing heavy rainfall and flooding in Central and also Eastern Europe. Here we have some more consequences of the climate change, which causes huge economic losses, which has been greater during the last years. And we also have a recent example from Valencia, where hundreds of people dead. Many places received more than 300 liters of water per square meter. Tens of thousands of people in Valencia were without power, and transport was disrupted. Many businesses located on the ground floors of buildings had to face many issues with the mud and the water, while many hectares of crops were also affected. Here we have some more numbers. At the right of the slide we can see the European map, which according to the IPCC report has been divided into three climatic zones. According to this report, and as we can see at the left part of the slide in this table, we can see how these hazards will go on. And as we can see, all of the hazards will become more frequent during the next years. And we can also see that the CO2 concentrations will also increase. These predictions are mainly of high and medium confidence. And what it means for the building stock in Europe. All these hazards affect the built environment in multiple scales, given that when we talk about built environment, we not only mean the buildings but also the infrastructures. As we know, the majority of the buildings in Europe are old ones. And this means that they are not energy efficient and they consume huge parts of amounts of energy, and the buildings are susceptible not only to the heat waves but also to extreme low temperatures. Buildings are also affected by the intense rain, which has indirect but also direct impacts on buildings. Moreover, Southern Europeans faces the issue of water scarcity, and these issues are more evident during the summer period. While I would also like to mention wildfires, which is also a climatic hazard, and here in Greece we face this problem every year, and we have here the example of the previous year, when thousands of residents and tourists were evacuated because of wildfires. So we can understand that we need to act, and we need to be prepared for all these consequences of the climate change. This is what Multi-Climate Project aims to do. Multi-Climate Project aims to assist citizens and stakeholders in evaluating the built environment and its inhabitants' resilience against locally relevant natural and climatic hazards, and also to improve their preparedness and their responsiveness throughout their lives. Now we are at the second phase, at the beginning of the second phase of this project, which is the developing phase. Today we will discuss the results from the first phase. In this context, in the context of the first phase of the Multi-Climate Project, we had an overview of the existing energy solutions that can contribute to the climate proofing of the built environment. This overview was based on several sources, including scientific papers and reports, guidelines and tools from the European Union. We gathered several interventions and solutions, and then we evaluated the solutions based on key criteria. We took into account their effectiveness, their affordability, and their implementation. And I would also like to highlight that we also considered a significant issue, which is the self-sustainability of the buildings when disruptive events take place. Here we have a flowchart of the methodology that we applied in order to collect and evaluate all these solutions. First of all, we categorized the solutions based on the scale, because we identified solutions on a building, urban and territorial scale. We dealt with several hazards. We took into account extreme temperatures, either low, either high, storms, extreme rainfall, wildfires, droughts, and we also considered earthquakes. I know that this is not a climate change hazard, but they also happen and have several impacts on the built environment. We identified different kinds of solutions, namely education solutions, tools, nature-based solutions, governance and engineering solutions. We evaluated them based on TRL and SRL levels, which are some levels to evaluate the states of the intervention. For example, if this intervention is still on testing stage, or if the solution is already applied, and which is the performance of the solutions, has the solution been evaluated or not. You can find the levels online. Then we considered the contribution of the solutions into climate mitigation and categorized the solutions based on the time when they act. For example, we have defensive, restorative, short-term and long-term solutions, because we need to act before the hazard comes in order to be prepared, but we also need to act during the hazard and after this. We collected several solutions, and after the assessment of them, based on several criteria, we concluded to propose 30 energy solutions. As we can see, we have several solutions, such as parks, which can contribute to reducing the effects of heat waves. We propose also the energy storage, the establishment of sensors on buildings in order to reduce the energy consumption. And as I can understand, the main question is how easy is to select the best solution for each case. It is not easy, and we cannot answer this question so simply. The selection of the solution demands building typology, demands climate risk assessment of the region in order to know what hazards we have to face. Sometimes we face some difficulties in the implementation of the solutions, because not all solutions fit to all buildings. For example, some of the proposed solutions cannot be applied in the existing buildings, but they can be applied in the new constructions. Of course, an issue is always the affordability of the solutions, because some of them are expensive, or they have high maintenance costs. Some other solutions are more cheap. For example, to create a green balcony can be a very low-cost solution. And to conclude, you can find more details about the existing and the proposed solutions in our publication, where we also discuss in detail the advantages and disadvantages of each solution. And regarding the future work, in the second phase of multi-climate project, we will proceed to a building typology, climate risk assessment, and the feasibility study in order to apply some of the identified solutions into the Camerino municipality. And we are going to publish our new results. Thank you.
Thank you very much.